If you watched my last video, you would have learned the Python basics. In this video, we're doing an exciting part. We're going to turn that knowledge into the real machine learning skills. The quick reality check about it is that knowing Python itself, it doesn't mean that you can do a machine learning. You need to master the machine learning based libraries. Today, I'll show you the 3-step method that I use to go from the absolute Python beginner into the intermediate stage where I can compete in the data science and machine learning competitions. Let's go. Okay, before we dive in, let's define on what knowing Python-based machine learning programming is. It actually means the two things. The first thing is that you know the Python fundamentals, which you would probably have it at this point. And second thing is machine learning library expertise. This is what we're building today. What are the libraries? It means it is the pre-written code that helps you work efficiently. Instead of code that you have to write everything from scratch, it's somebody else that have already written in a proven way, saved in a GitHub. The essential 3 libraries in machine learning basics that you need to know is Pandas, Numpy, and Scikit-learn. The Pandas and Numpy is more like a calculator of the code. Pandas helps you do a data manipulation and analysis. Numpy is more numerical computing, more like a mathematical engine. The Scikit-learn is about the machine learning algorithms. Data scientists and data analysts often heavily use the Pandas and Numpy. First is Pandas and Numpy, your Python calculators. These handles the data processing and think of them like Excels on steroids. My recommendation about learning the Python, Numpy, and Pandas is using Kaggle's free course. Kaggle free course, it offers interactive notebook that you can write down and understand the basic command lines of the NumPy and Pandas. How you can access is go to the Kaggle, click Learn in the menu, start with Pandas course, then complete the NumPy course. It often have 4 to 5 stages, which is quick and simple, that even people who's working in the industry between your days, you can easily put your hands on and complete it. When you complete this Kaggle, NumPy, and Pandas course, you'll be able to understand how to load the data, how to clean it, and how to manipulate it. Don't worry about memorizing every function. As I always say, you'll come back eventually and there'll be aha moment that you can understand what you have learned. After you finish Pandas and NumPy, you're ready to move on to the Scikit-learn. Scikit-learn is very classic, traditional, but also powerful machine learning library. This is where beginners become practitioners. When you're first learning Scikit-learn, the fastest way to learn is mimic the expert's code. People say the true creativity comes from the imitations first, right? It also applies same in the programming world. The method that I've used is called a deep copying. First thing you should be doing on a phase 1 is find your learning material. Go to Kaggle, go to competitions, start with the beginner's competition. The classic recommendation for everyone would be Titanic. Second would be house pricing prediction. Click one of the competition and go to the code tab. If you go to code tab, you'll be able to sort it out with the highest of votes. It means many people refer to that code while they're studying, and these are probably the best quality and proven code that you can rely on. After you chose the codes that you want to benchmark on, the phase 2 is the retyping process. Here's what people get wrong. They just read the code and say, oh, I understood this way. Maybe I can apply it. But what you should be doing instead is copy the notebook to your own account. Retype the entire notebook from scratch. One single line, one different naming. Just see how they named each variables, how their programming style is, observe it. Try to learn the best parts of it. When you retype, don't just copy and paste it. Type every single line and try to think about it. Why did this person write this code this way? What does this code actually do? How it changes the data? So my experience is when I set the notebook that I want to benchmark on, I rewrote the same code from end to end 5 to 7 times until it imprinted in my own mind and hand. So why this works is because your finger learns the syntax pattern. You learn about how the code is consistent. Is it organized in a readable, understandable way? By the way, I think this benchmarking from the best practice approach is the best because if you want to change your career towards software engineer, data scientist, or machine learning engineer, writing the clean, organized code is also one of your key skills that you should have. If you know how to write a code, but if your code is messy, no one would take into account. you'll be screened on the programming interview. So keep that in mind and try to learn from the best experts. Phase 3 is study multiple approaches. When you copy and paste and retype all the notebook's lines, do not focus on only one notebook. Study at least 5 or 7 notebooks from different people. What you'll discover is, let's say, the person A focuses on a feature engineering from behavioral traits, and person B, they use the changes on the model design using ensemble method combining the multiple models. And person C, what they did is they created clever data transformation methodology that people haven't thought of or referred to the domain expertise. And person D, they took the task completely into the different approach. Like this way, there's no single right answer in the machine learning. I believe there's also a part of some creativity of how you approach the same problem. By looking at the different perspectives of how they approach the same machine learning task in a different way, you'll be able to embrace not just how to code, but how to think like machine learning engineer. And you can start picking up the idea about which part I can be creative and what are the standard options that I can manifest. But what are the parts that I can step ahead? What are the recent researches that show that takes a different approach compared to the existing notebooks? The last phase 4 that you should be doing is identify the pattern. As you study through the multiple notebooks, ask yourself, where did the person add creativity? What techniques appeared in multiple top solutions? What approaches were effective or ineffective? How do experts structure this issue when the task is given? Now that you have read through the best practice notebooks and you kind of know how to solve the existing task, the Titanic task or house pricing prediction task, now is the time to test your knowledge. Here's the way I used. It might sound a little lame, but this is very effective. I call it the blank document test. If you're feeling lost and you're not sure how far you've learned, and try this exercise. Open up your empty document page. I'm not talking about IDE or notebook, just like Microsoft document. And if you open up, you'll see a blank text document that have nothing. And then start writing down what you have learned. With in an absolute blank page, you'll be able to vividly show which part is missing in your machine learning. Am I not doing well on a data loading? Am I confusing certain functions? Or am I missing out the key stages that I shouldn't be overlooking? So this filling the gaps of your knowledge by putting yourself out there in a blank page, it'll be the perfect indicator of what you learned and what you haven't learned. Thank you for everyone who's been following this video all along. If you've done this far, you're ready to compete. The next stage that you should be following is competing in the competition with the different people. In the next episode, I'll share about the key resources and the competitions that you can join to put your programming level into the other level. Hope this was helpful and stay tuned. Bye.